Hello everyone, a very good evening. I hope I'm audible and visible. So let's wait for 5 to 10 minutes so that everyone can able to join this session. Okay, let's start the session. Hello everyone, my name is Pooja Verma. I am PMR Research Scholar from IIT Kharagpur. And the instructor for this course is Professor Shantanu Gopandya, Electrical and Electronics Engineering Department, IIT Kharagpur. This is a week 12 live and interactive session on digital circuits. You can use chat box for asking and interacting the questions. So these are the topics which have been covered for this week video lecture. I hope all of you have gone through this week video lecture. So this is the last week for taking this session. I will take one more extra session for doubt clearing. So we will see in that session. Sorry, I had to prepone this session for some urgent work. So I hope all of you have gone this week video lecture. So moving to the question that is related to this week content. Okay, I hope I'm audible and visible. So, okay. So first question is the interrupt in an 8085 microprocessor that is not affected by the value of the interrupt enable flip-flop. Is option A is interrupt, option B RST 7.5, option C is trap, or option D RST 5.5. The question is the interrupt in an 8085 microprocessor that is not affected by the value of the interrupt enable flip-flop. So which interrupt is not affected by the value of the interrupt enable flip-flop? So these are the options which can be correct. So option C will be the correct one. Okay, because trap is a non-maskable interrupt. Option C will be the correct one because trap is the non-maskable interrupt in a 8085 microprocessor and it is not affected by the status of the interrupt enable flip-flop, meaning it cannot be disabled or masked by the software. Okay, it is not affected by the status of the interrupt enable flip-flop. That means it cannot be disabled or masked by the software. It has a highest priority among all the interrupts and it is also S and level trigger interrupt. But other interrupts like interrupt RST 7.5, RST 6.5 and RST 5.5 are the maskable and are the controlled by the interrupt enable flip-flop. But trap is not a maskable and controlled by the other flip-flop. Okay, so meaning that can be enabled and or can be disabled. So only trap is the only interrupt that is unaffected by the value of the interrupt enable flip-flop. Okay, so correct option will be the option C. Okay, okay. So moving to the next question. Which of the following statements regarding 8085 interrupts is false? They are asking following statement regarding 8085 is false. So from which is a false statement. So option A is the interrupt is a process that starts from an input output device and is asynchronous. Or option B, an interrupt can be either be a maskable or a non-maskable one. Or option C is an interrupt can either be a vector or non-vector one. Option D, an interrupt is serviced only after the microprocessor completes the execution of its current program. Okay, so let's go option by option. So option A is an interrupt is a process that starts from an input output device and is asynchronous. So that is true. Interrupts are generally triggered by external devices and are asynchronous to the program's execution. Okay, so interrupts are process that start from the input or devices and are asyncronous. That one is a correct. Okay, so it is a not a false statement. So already as the here is described, generally triggered by the external devices and are asynchronous to the program's execution. Okay. Now next is the option B. An interrupt can either be a maskable or a non-maskable one. So already we have studied this. Interrupts are maskable and non-maskable both. Some interrupts are maskable and some interrupts are non-maskable. So already we have seen in the previous question. So trap is a non-maskable interrupt and other are a maskable interrupt. So there are 5 hardware interrupts. Already we know that 5 interrupts are there. So one is interrupt, sorry, interrupt RST 7.5, RST 6.5 and RST 5.5. Another one is a trap. So this trap is a non-maskable interrupt. Here interrupt and all others are maskable interrupt. Interrupt. So okay, so this statement is also an interrupt and either be a maskable interrupt or a non-maskable interrupt. Similarly, the another option C is an interrupt can either be a vector or a non-vectored one. So this one is also true. So vectored interrupts are predefined memory location where the program execution jumps after an interrupt. Okay, so already 5 interrupts are there. That is interrupt, RST 7.5, RST 6.5, RST 5.5 and trap. Okay, but here only interrupt. This one is a non-vectored interrupt, non-vectored interrupt and all other are vectored interrupt. Okay, so basically there are 5 types of interrupt. One is the interrupt RST 7.5, RST 6.5, RST 5.5 and trap in which in all the first words are maskable interrupt and trap one is a non-maskable interrupt. Similarly, the interrupt is only non-vector and all other are vector interrupt. Okay, so option C is also a correct one. An interrupt can either be a vector or a non-vector. Okay, so this one is also correct. Let's see the last option. Last option is an interrupt is serviced only after the microprocessor completes the execution of its current program. No, it is a false statement because an interrupt temporarily halts the current program and microprocessor immediate service the interrupt by executing the corresponding interrupt service routine, after which it resumes the interrupt program. So the program does not have to finish completely before the interrupt is serviced. Okay, so an interrupt is serviced only after the microprocessor completes the execution of its current program. No, this one is a wrong one. Okay, so when the interrupt microprocessor stops the current execution and check the interrupt, then it will resume later the current program. Okay, so option D is the correct answer for this. This statement is false. So they have asked which of the following statements regarding 8085 interrupts is false. So this one is a false statement and all other are correct. Okay. Okay. So moving to the next question. I hope you understand this question. This is a basic questions related to interrupt. Okay. Okay. So moving to the next question. Which of the following statements regarding call and return instructions is false? Here they have again asked for false statement. Okay, just concentrate on this also. So option A is an 8085 program may contain multiple return instructions. Option B, in an 8085 program, the first call instruction may appear before the first return instruction. Option C, and in an 8085 program, the first return instruction may appear before the first call instruction. Or option D, an 8085 program may contain multiple call instructions. Okay, so which statement is false? So let's go option by option. So an 8085 program may contain multiple return instructions. That is true. And any program can contain multiple return instruction. Okay. So here description is already given here. So this one is a true. A program can have a multiple subroutines and each subroutine ends with a return instruction to return to the calling program. So therefore multiple return instructions are allowed in a 8085 program. Okay. So this one is a correct. Now go to the next option. So in an 8085 program, the first call instruction may appear before the first return instruction. Yes, this one is also true. So first we have to take call instruction, then return, because return that means halt the current program. Okay. So the call instruction is used to call a subroutine, and once subroutine is completed, then return instruction is used to return to that point where subroutine was called. So first call instruction are called, then after that return instruction will appear in any program. Now next, when we see in an 8085 program, the first return instruction may appear before the first call instruction. So this one is the no, this one is a false, because it is just replacing the call and return. So before we have seen that first we need to call for instruction, then we have to end the program by returning at that location. So here they have asked in an 8085 program, the first return instruction may appear before the first. No, it is not possible. Okay, so first we have to call the instruction, then we have to return. So this one is a false statement. So option D is the correct one. The N8085 program may contain multiple call instructions. Yes, it can contain multiple call instructions within a different subroutines from various points in the program. Okay, so this one is also correct. So option C is the correct answer for this question because it is a false statement. Okay, so this one is a false statement. So that's why it is a correct option. Because they have asked in the question which of the following statements regarding call and return instruction is false. So they have asked for false statement. So false statement is option C. Okay. Okay. So moving to the next question. Okay. So next question is which of the following statements about the stack in an 8085 microprocessor is false? So here again they have asked for false statement. So we have to check the options. So option A is stack is a last in first out structure. Okay. Option B, size of the register associated with the stack in 8 bits. Option C, information is saved on the stack by pushing on it. Option D, information is retrieved on the stack by popping it off. Okay, so already we know that stack is a last in first out instruction. Whatever content will come in the last, the whatever content will be come in the last, that will be stored in the upper, and that will be called the first. First it will be out. Okay, so the stack in 8085 microprocessor follows the last in first out LIFO principle, meaning last value pushed onto a stack will be first one will be popped up or come first. Okay. Now next one, size of the register associated with the stack is 8 bit. No, this one is a false, because size of the stack pointer in a 8085 microprocessor is a 16 bit, not a 8-bit register. Okay, size of the register associated with the stack is 16 bit, not a 8 bit. That's why it is a false statement. Okay, and it allows stack to address 16-bit memory location. Now next one is the information is saved on the stack by pushing on it. Yeah, correct. Whatever information is there, by pushing in the stack, we can save it in these places. Okay, so data is saved to the stack by push instruction, which stores information in the memory starting from the location point to the stack. Whatever it is pointed, where there will be stacked from there. Okay, and the information is retrieved on the stack by popping it off. Yes, the data is retrieved from the stack using the pop instruction. By push instruction, we can save the data on the stack, and by using pop instruction, we can pop off or we can take data from the stack pointer. Okay. Okay. So this option B is a false statement. That's why it is a correct option for this question. Okay, because they have asked for the which statement is false. So option B is a false statement. That's why it is a correct answer for this question. Okay, okay. So I hope you are getting it. You know, when exam is waiting, so I will just taking the question and solving it. So I hope you will understand. And all these are the theoretical questions you also get from your notes or lecture material. Okay. Okay. So moving to the next question. So next question is, with respect to an 8085 microprocessor, match column X and with the column Y. So here in the column X, we can see that different interrupts are there. That is interrupt RST 5.5, trap and RST 1. Okay, in the column Y, their features, or you can say that their features are there hidden, which one is a non-maskable interrupt, maskable, software or non-vector. Okay, so already told you there are 5 hardware interrupts. Basically, there are 5 interrupts are there. That is called a hardware interrupt, and 7 software interrupts are there. Software interrupts are there. That are, you can say, RST0 to RST1, RST2, RST3, RST4, RST5, RST6, sorry, 8 software inputs are there, and RST7. Okay, and 5 hardware interrupts already you know that is interrupt RST 7.5, RST 6.5, RST 5.5, and trap, and in which there are maskable, non-maskable, and vector, non-vector interrupts are there. Okay, so already we know that interrupt. So interrupt is a non-vector. Interrupt is non-vector and all other are vector. And similarly, interrupt is non-vector and maskable. And trap is vector and non-maskable. Okay, and all these IST 7.5, 6.5, and 5.5 is vector and maskable interrupt. Okay, so let's match the column X with column Y. So interrupt is already told you a non-vector. Okay, so it is a non-vector, and RST 5.5 is maskable interrupt. Okay, because only trap is a non-maskable interrupt and all other are maskable interrupt. So now trap is a non-maskable interrupt, right? Because it is the only interrupt which is a non-maskable, and RST1 is a software interrupt. Already told you 8 software interrupts are there, that is RST0, RST1, RST2, RST3, RST4, RST5, RST6 and RST7. Okay, so let's see X, which option can be correct? One column X, you can say that X1 to Y4, X1 to Y4, now X2 to Y2, X3 to Y1 and X4 to Y3. So if you match that, you will get option B is the correct answer for this question. Okay, so option B is the correct answer for this question. Okay, so I hope you understand this question. So moving to the next question. Okay. So next question is, to which pin external DMA controller sends a control signal to an 8085 microprocessor? To which pin external DMA? DMA stands for direct memory access. Controller sends a control signal to an 8085 microprocessor. Option A is hold, option B is HLDA, option C is interrupt, and option D is interrupt. Okay. So through which pin external DMA controller sends a control signal to an 8085 microprocessor. So in an 8085 microprocessor, the hold pin is used by an external, or you can say that DMA direct memory access controller to request control of the buses, that is data, address or control buses. There are three types of buses in the 8085 microprocessor. First one is the data bus, then address bus and control bus. So hold pin is used by an external DMA controller to request to control these buses. Okay. So when hold signal is received by an 8085 microprocessor, it completes the current instruction and relinquishes control of the buses by sending the acknowledgement to a HLDA, hold acknowledgement pin. Okay. And interrupt and inter pins are used for interrupts, not for DMA. So only hold pin is used by the external DMA controller to control the buses. Okay. Okay. So option A is the correct answer for this question. Okay. So I hope you understand this question. So moving to the next question. So next question is, which of these is not an error checking method? Which of these is not an error checking method? Option A is parity check, option B is checksum, option C is cyclic redundancy check, or option D is Huffman code. So already we know that parity check, checksum and cyclic redundancy check are used for error checking, and Huffman code is not used for error checking. This is a data compression technique, not an error checking method. It is used to reduce the size of the data by assigning shorter codes to more frequent characters and longer codes to a less frequent characters. Okay, so Huffman code is used for a data compression, data compression, not a error checking. And all these are used for error checking. So parity check, already we know that we in the parity check we add extra bit, or we can call it parity bit, to ensure that the number of set bits is in even or a odd, to check whether there is any error while we are sending from the source to destination. So we will add a extra parity bit to check the error. And now next one, checksum. A checksum is a value derived from the sum of all data types used to detect error in a data transmission. It is used to detect the errors in a data transmission. And cycling redundancy code check, or you can say CRC, is a method detecting errors in a digital data to performing polynomial design, polynomial division. Okay. And the last one is Huffman code. Huffman code is used for the data computation. So it is a not a error checking method. That's why it is a correct answer for this question. Huffman code is not an error checking method. Okay. It is a data compression technique. Okay. So moving to the next question. The next question is, after the execution of instruction RIM, the accumulator contained 49 heads in hexadecimal. Which of the following statement is true in this case? So, which of the following statement is true in this case? Option A is RST 5.5 is enabled and is pending, or option B is option RST 6.5 is enabled and is pending, or option C RST 7.5 is enabled and is pending, or option D is none of the given option. So they have asked, after the execution of the RIM instruction, the accumulator contained, that means accumulator contained a 49 H. So which statement is correct? So RIM stands for, already I think you know that RIM stands for read, let me write it correctly, read, interrupt, mask. Okay, it is a one byte multi-purpose instruction used to check whether RST 7.5, RST 6.5 or RST 5.5 are masked or not, to check whether the interrupts are enabled or not, to check whether the RST 7.5, 6.5 and 5 interrupts are pending or not, or to perform the serial input data. Okay, so RIM stands for read, interrupt, mask, used to check whether RST 7.5, RST 6.5 or RST 5.5 are masked or not, and these interrupts are pending enable are pending or enable to perform serial input data, serial input data. Okay, so how we can check whether these interrupts are enabled or pending or masked or not? So I hope all of you have studied about the RIM instruction, that register RIM instruction, that is register, you can say. So what different blocks will represent. Okay, so it is a SID, serial input data, serial input data, and this one is a interrupt IP 7.5. This is a IP 6.5. This one is IP 5.5. That means, this means interrupt pending status. Interrupt pending status. Okay. If it is a 1, so interrupt pending, or it is a 0, it is a not pending. Okay. Now next one is a IE, that is called the interrupt enable. Interrupt enable. Okay. Now next one is a M7.5, M6.5. There is one more block. This is a M5.5. Okay, this is called mask status. Mask status of ring. Okay, if it is a 1, it is a mask, 0, not mask, or you can say unmasked. Okay, so how we can check from here? So how we can check? Already we know that the accumulator data is a 49. Okay, so we have to put, this is a bit number. So 49, accumulator contained a 49. So how we can represent it? 0 1 0 0 1 0 0 1, right? So if you compare 0 1 0 0 1 0 0 1, okay, so from here by putting the accumulator bit here, you can check it in which state the rim instruction will be executed. Okay, so that means where it is 0, that means serial input data. Serial input data is disabled. Okay, that is a no serial input data communication will be occurred. Now next in IP 7.5, it is 1. So that means interrupt is pending at 7.5, at RST 7.5. It is a 1. That means interrupt status is pending. Okay, RST 7.5, and all other interrupts are disabled. That means it is 0 0. That means it is not pending. Okay, now next one is here, it is 1, right? Interrupt enable. So that means interrupt is enabled. Okay, now next second is 0 0 mask 7.5 mask system. That means these are the unmasked, only M5.5 are the masked. That means interrupt, sorry, RST 5.5 are masked. RST 5.5 is masked. So these are the final conclusion for this accumulator contain 49H. So which of the following options, these are the final conclusion from the RIM instruction. What RIM instruction is saying. So at RST 7.5 is 1, that means interrupt status is pending. So let's go by the options. RST 5.5 is enabled and is pending. So RST, it is masked is enabled, that means interrupts are enabled. Okay, but interrupt 5.5 and 6.5 are not a pending status. Okay, there is a no pending instructions will be there. So that means 5.5 and 6.5 are wrong. Okay, now check for RST 7.5 is enabled and is pending. Yes, it is showing that the interrupt 7 RST 7.5 is a pending status and enabled, because interrupt is enabled and pending. So that's why option C is the correct answer for this question. Okay. So now next option is D. None of the given option. No. Option C is matching, because RST 7.5 is equal to 1. That means interrupt status is pending at the RST 7.5. There is a interrupt. Okay. And interrupt is already enabled, because here it is a 1. And mask still mask, they have nothing written in the options about the mask status. So that's why we are not considering here. But if there is an option related to mask, so you have to check whether the it is RST 5, 7.5, 5.5 and 6.5 are masked or not. They can ask this type of question also. Okay. So just you need to check the RIM instruction. RIM instruction. Okay. So from here you can check it and take a final conclusion that the RIM instruction is which state will be there after the execution of the instruction RIM. The accumulator contain this. So just we have to take binary of this and check in which state the RIM instruction is there. Okay. Okay. So option C is the correct answer for this question. So I hope you understand this question, how to solve this type of question. So just you remember, you need to remember this one, RIM instruction register. Okay, what every stage is saying. Okay, just you remember this one. Okay, so you can able to find. So what the instruction is saying. Okay, what does it mean? Okay, so I hope now you understand this question. So moving to the next question. So next question is the ready pin of the 8085 is used for which purpose ready pin is used in 8085. Okay, so option A, by the microprocessor to tell the device when it is ready. Option B, by the device to tell the microprocessor when it is ready. Or option C, for input or output operations. Or option D, all of the other three options. Okay. So what does ready pin is mean? So first we will see what does ready pin is mean. So the ready pin in 8085 microprocessor is used by a external device to signal to the microprocessor that they are ready for the data transfer. Okay. So already here it is described microprocessor is used by a external devices to signal microprocessor they are ready for a data transfer. So it is used by a external device or any other device. Okay. So if a device is not ready, for example, it is slower device, the ready pin can be used to insert wait states in the microprocessor operation, allowing the slower device to complete operation before microprocessor proceed. Okay. So when ready signal is high, that means the microprocessor continue its operation, or when ready pin signal is low, microprocessor wait until the device becomes ready. Okay. So external devices used for ready pin to signal when they are ready for the data transfer. Okay, so option B is the correct answer. By the device to tell the microprocessor when it is ready. Okay, so ready pin used by a device or external device to tell the microprocessor when it is ready. It is not used for input output operation or not used for a microprocessor to tell the device it is ready. Okay, so option B is the correct answer for this question. So I hope you are understanding all these questions. So moving to the next question. The next question is in 8086, the address bus is bitwise. Bitwise. What is the address bus for in 8086 microprocessor? So in 8085, the address bus is 16 bit, right? But in 8086 address bus is 20 bit, 20 bit wide. Okay. So how much the total addressable memory? What will be the total addressable memory? That is 2 to the power 20. Okay, approximately 1 megabyte. Okay, so in 8086 the address bus is 20 bits wide. Okay, so that's why option B is the correct answer for this question. So in 8085 it is a 16 address bus is a 16 bit, but in the 8086 it is address bus is 20 bit wide. Okay, okay. I hope you are getting this. So moving to the next question. The next question is which of the following pins in an 8086 microprocessor are multiplexed with data and addressing? That is option A is AD15 to AD0. Option B is AD19 to AD0. Option C is AD19 to AD1. Or option D is AD19 to AD4. So the question is which of the following pins in an 8085 microprocessor are multiplexed with data and address bus. So already we know that address bus is 16 bits, sorry 20 bit, it is a 20 bit, okay. So it is a 20 bit. So how many data it can multiply from AD0 to AD, that is 8 to 15, not 0 to 19. All we cannot multiply. Okay. So the microprocessor 8086 has total 26 to 40 pins. 8086 has total 40 pin IC, out of which 16 pins, that is AD0 to AD15 are multiplexed. Let's address and data. Okay, data signal. So option A is the correct answer for this question. Okay, so moving to the next question. Okay, so next question is which of the following is not a data transfer instruction in an 8085 microprocessor? Which of the following is not a data transfer instruction in an 8086 microprocessor? Option A is move, option C, B is XG, or option C is SBB, or option D is push. So already we know that move is the instruction used to transfer the data from one location to another location. For example, we already have seen that move A to B or A to be somewhere else. Any memory register or memory operation. So it is used for data transfer from one place to another place. Now next one is exchange, that means exchange. The instruction exchange the value between the two operands. Okay, effectively it is also a data transfer between them because it is the exchange HG, HL to DC. You can say that it exchange between the different memory locations in the register. Or option C is subtract SPV, that means subtract with borrow. So this is a arithmetic operation. This is not a data transfer of data transfer operation. It is a arithmetic operation subtract. So that subtracts from the source operand and borrow flag from the destination operand. So it is not a data transfer operation. It is a arithmetic operation. Now push next one is a, so option C is the correct answer. SVB is not a data transfer instruction. Okay. So push is also used for data transfer from one place to another place. Or we can write a push any information that will store in the top of the stack. Okay. So option C is the correct answer for this question. SVB is a arithmetic operation, not a data transfer instruction. Okay. So moving to the next question. The next question is which of the following is not a valid 8085 instruction? So instructions are like that. Option A pop PSW, pop B, pop C or pop D. So I hope you have listened about these instructions. So you can easily identify which instruction is not a valid instruction. So pop PSW. The first what the pop instruction will do. So pop instruction is used to pop the data or come out the data from the stack. Okay, stack into register. So pop instruction is used for to taking a data or pop the data from the stack. So pop PSW means pop the program status word which contains the accumulator and flag. Okay, from the stack. So it is a valid keyword. Now pop B. So pop the data into a register B and C. It is also a valid or a pop C. So there is a either we can use pop B, not a pop C. So from the by writing the pop B, we can take the data from both the register B and C also. There pop C instruction is not mentioned anywhere. It cannot pop the directly data single register like C. Okay, so this is a not a valid. Similarly, pop D. So this is pop the data into a register D register D and E. Okay, so we cannot pop the data on the single register. So pop C is not a valid 8085 instruction. Okay, so option C is the correct answer because pop C is not a valid 8085 instruction. Okay, okay, I hope you understand and you are getting these questions and answers. So moving to the next question. Okay, so again, next question is related to 8085 and matching between the different columns. So question is the with respect to 8085, match column X with column Y. So column X is given as RST5 from different interrupts are given. So we match with the whether it is S triggered or level triggered. Okay. So RST5.5, RST6, RST7.5 and RST4.5. So already we know that these are the hardware interrupts and this is the software interrupt. So option 2 is matching with the option 4. RST6 is the software interrupt. Okay. And let's see which interrupts are S triggered, level triggered or both. Okay. So trap is also called a RST 4.5. Okay, so RST 5.5, whether it is a level trigger or S trigger, so it is a level trigger. RST 5.5 is a level trigger. It requires a constant signal to keep the interrupt active. Okay, RST 5.5. And RST 6 is a software interrupt. Already we know that. RST 5 7.5 is S triggered only. It responds to the transition of the signal. Okay, and RST 4.5 is as in level trigger. It cannot respond. It can respond to both types of signal, S triggered signal as well as level triggered signal. Okay, so let's take which option it is matching. So X1 is matching to Y2, X2 is related to Y4, and X3 is related to Y1, X4 is X, sorry, Y3. Okay, it is a Y4. Okay, so let's match which option is matching. X1 Y2, X2 Y4, X3 Y1, and X4 Y3. So option D is matching with this. So option C is the correct answer for this question. Okay, so I hope you are getting it. So moving to the next question. So next question is in 8085 the numbers 45X and 7E are added, the resulting flag settings will be as. Okay, so if we add these two numbers, what will be the flag status? We need to check. So we need to add these two numbers, that is 45 in hexadecimal, and the 7E is also in hexadecimal. Okay, we can add it directly, otherwise you can also convert it into a binary, then add it, then check, because in the flag status we need to check from the binary only. Okay, okay, so E means 14, right? So 14 plus 5, 19, and 0 to 15 is there only. So 0 to 15, so 16 is 0, 17 is 1, 18 is 2, and 19 is 3. So that means 3 and 1 will be in the 7 plus 4, 11, and 1 is then 12. Okay, and plus 1 will be the carry. Is it there? So you can say that 12 is represented by which one? 10, 11, 12, 3, 3. Or we can directly change it in the. So that means there is a carry, or also carries forwarding to the next bit. So there will be the auxiliary carry will be there. So just check with the binary number, you can able to understand more. So 4 is representation is 0, 1, 0, 0. 5 is represented by 0, 1, 0, 1, right? 7 is represented by 0, 1, 1, 1, and is the stand for, that means 14. So 14 is represented by 1, 1, 1, 0. Now we need to add it and check. 1, 0, 1, 1, 0, 1, 1, 1, 0, 10, 1, 0 again, 1 carry will be there. Right, now next carries forwarded in next 4 bit. So 110 again 110, 110 again 1 carry 1 will be there 7, right? So which option? So auxiliary carry will be there, right? Because after 4 bit there again carries forward to the next 4 bit, so auxiliary carry will be 1. And what about the carry So there is a no carry generator, so carry will be the 0. Okay. So carry will be reset and auxiliary carry will be set, because auxiliary carry is forwarding the next 4 bit. After that there is a carry, so that's why auxiliary carry will be 1. So option C is the correct option. That means carry is reset and the auxiliary carry will be set. So option C is the correct answer for this question. Okay, so there is a no carry will be forwarded. C only will be the answer. Okay, so the resulting flag status will be the auxiliary carry will be set and carry is reset. Okay, so option C is the correct answer for this question. Okay, so I hope you are getting this question. So moving to the next question. So next question is from the programming. So for an 80855 processor, the following program is executed. So NVI A, that means move immediate data to in an accumulator, that is A is equal to, so I'm writing here like this, A that means 0.5 load in accumulator data immediate in a accumulator 0.5. Now load in the register B 0.5. Load immediate in register B is equal to 0.5, it is given. Now PTR add P. Here PTR is acts as a point of reference for subsequent jump instruction. Okay, for jump instruction it is pointed out. So next operation is add B. That means add the register B with the accumulator and store the data in a accumulator. So A already we know that 5 it is. So A will be now accumulator is 10 H. Okay. Now the accumulator containing 10, or we can directly say that 5 then 0. So you can write 0 A H. Okay. You can write it 0 A H. Okay. Now what we need to say, now next are saying that TCRV. TCRV. So this is a this one. Now decrement P. That means decrement the register P. Decrement register B. Okay. So currently in the register B the data is 0.5. Okay. Now B register is decremented by B minus 1. That means 0.4 will be the content in the register B. Now J and Z PTR. That means jump if not 0 to the this location PTR. Okay, decrement B and jump to the, just follow this loop till now where it is the decrement B will be the 0. Okay, this loop is goes through add B, decrement C and till B is 0. Okay, till B is equal to 0. So let's see what will be the content. So now next operation is add B. Okay, so add the B containing 0.4. So add B in the accumulator. So currently accumulator, what is in accumulator? So A 0. So A will be, add B means A plus B. So current accumulator contains 0A plus 0.4. What will be the content? A means 10. 10 plus 4 14. So it will be 0E. Right? The content in the accumulator now 0E. And again now next is decrement B. So B is equal to B minus 1 till 0.3. Okay, now B contains 0.3 and accumulator contains 0E. Now next again we have to do this operation till B is equal to 0. Again add b, so that means a is equal to a plus b. Now b is containing 0e plus 0 3. So e stand 15, right? Now it's 14. So 14 plus 3, what will be the, that one carry will be there, and again 1. Okay, so 14 plus 15, 0 1. Okay, 14 means e. If you add, it will go till 15. So 15, 0 3, 7 1, right? So it is, we cannot write it 7. 14 after 15 till 0 1. Okay, so it is 1, and there is a 1 carry, 1 1. Okay, and now again we will decrease b minus 1, that means 0 2. Again it will jump till b is not 0. Okay, so again accumulator will add a plus b, that means how much in accumulator? 1 1. 1 1 plus 0 2, that means 1 3. Accumulator contains 1 3, and I'm writing here. After this I'm writing here. After this I'm writing here. I can remove it from here so we can understand it better. After this I am writing here. After this I'm writing here. So I'm writing here. Okay. So now accumulator is containing a is equal to 13, and b will be the b minus 1. That means b will be the 0 1. After b till b is 1 left, so we have to again perform again add b. So that means a plus b, and store in a is 13 and b is 0 1, which is a 14. Okay, 1 4 in hexadecimal, and b is equal to 0 0. Now b is 0 0, so just we have moved out from the loop. So now it is saying that add immediate 0 3 in the accumulator. So now currently accumulator is containing 1 4. So add 0 3 immediately. So 1 7. Okay. So what will be the final content in the accumulator? What will be the final content in the accumulator? That is 17H. And then end of the program. HLT means end of the program. So at the end of the program, accumulator contains, that is 17H. Okay, so accumulator contains the 17H. Okay, so here we have seen that in the last accumulator is containing 14, and then after this instruction add immediate 0 3 in this. So after adding, it is 17H. So final content in the accumulator is 17H. Okay. Okay, so I hope you will get this question. So moving to the next question. It is in loop. Okay, that is in loop. Jump if not zero, that loop PTR. Okay, so moving to the next question. So next question is, in 8085 microprocessor accesses two memory locations. These are the two memory, 2001H and 2002, that contain 8-bit numbers 98. That means in location 2001H, the 8-bit number contain 98H, and memory location 2002H, there is B1. Already this stored respectively. Okay, B1. So the following program is executed. This program is executed. So at the end of this program, the memory location 2003 contains the number of in decimal form. We have to take the number in decimal form. Okay, so already they are saying that it is stored in these locations. So first load LXI means load immediate data in HL register pair. So in HL register pair, load immediate data in HL register what data 2001. Okay, whatever in N, that means in H there is 20 and L there is 0 1 will be stored. Now next instruction is, that means in HL load immediate data in HL register here 2001. Okay, where H in which H will contain will 20 and L will contain 0 1. Okay, now move immediate data in accumulator. In accumulator, which data? 21H will be stored. Now increment, that is INX, that stands for increment. Okay, increment H, that means increment HL register there. That means increment HL plus by 1. Okay, so that means what is what is the location? That is 2001 plus 1. That means 2002H. Okay. So now add M. Add in accumulator reference data of add M means add in accumulator. M means memory location. Okay. In which that memory location contain HL register there. Okay. So add the reference data of the HL register there. Add the reference data of HL register there. Add reference data of HL register pair. So what is the reference data in HL register pair? In that that means already HL register pair has been incremented that location. So what data is stored in 2002, that is P1. So add reference data of the HL register pair. Okay. So that means with the accumulator add A plus, that means HL register pair. Okay, reference data. So what is the reference data of the A HL is B1? What is in data of A accumulator? In accumulator that is stored 21. 21 plus B1. Okay. If we add, you will get D2. That means 112. B means 11. 11 plus 2 means 13. 13 stands for D2H. If you add. So currently accumulator contains D2. Okay. So add M here, already we have added this part is here. Okay. Now increment HL register there. Again increment register there. HL plus 1, that means already it is in location 202 plus 1, that means 2003. So register pair location is updated, that is has gone to 003. So currently in 2003, which data will be there? So let's see. Again they are saying move M to A. That means move this accumulator content to a memory location. Memory location is stand for HL register where. So in the HL register where we have to locate this. So D2 will be transferred or moved to a memory location. Okay, move the content of accumulator to a memory. So that means HL register pair reference. That means at the location 2003 will be D2 will be stored and end of the program. Okay, so currently what will be which data is in HL register pair? That is D2 at the location 2003. Okay, so already we have seen that the at the end of the program the memory location 200 contain the data D2. So now contain the number it is given in hexadecimal. Now we have to change it into a decimal because in the question they have asked for a number in a decimal form, base 10 form. Okay. So how we can change it? D2 to decimal form. So I can change it here. D, D2. Okay. So how we can change it? Just a minute. So already we have. So D into 16 to the power 1 plus 2 into 6 to the power 0, right? So D means what is 13 into 16 plus 2. 6 to the 0 is 1. So 13 into 16 will be, what will be the value? What will be the value of 13 into 16? So 13 into 16 is 208 plus 2. So if you multiply it, so you will get 210. That in hexadecimal. So here what I have written, 2002 D2 will be stored at the end of the program. Okay. Now we have to, this D2 is in hexadecimal, so we have to convert it into a decimal because in the answer they have asked a decimal conversion. So what will be the value? This is 210. Okay, so 210 will be written here. Okay. So I hope you have got this question, how to solve this type of question. So moving to the next question. Okay. So next question is, accumulator has data FF. Okay. Determine the state of carry Z, that means zero flag, and sign flag when 01 is added and option 2 is the content of the accumulator is incremented. Okay. Okay. So question, accumulator is stored, that means accumulator is containing FF, right? We can write it accumulator. Now based on that, 1 is, what is it? 01 is added. So let's add in the accumulator 01. So FF stands for all one, right? So if we add 1, that means 0, 0, 0, 0, 0, 0, 0, 1. Okay, here it is given 01 H is added. That's why. So 110, again 110, 1 carry will be forward 0, 0, 0, 0, 0, and 1 carry will be the extra. So what is the status of the flag? So carry will be 1, right? Because in the last carry is generated, and 0 flag is also set because all the content in the accumulator is 0. So that's why 0 flag is set. Now next one is the sign flag. What will be the sign flag? Sign flag, there is a no negative number. So that's why sign flag is 0. Okay. So for option 1, that means 01 is added. These are the outcome. Carry flag is set, 0 flag is also set, and sign flag will be 0. Okay. Now check for the second statement. The content of the accumulator is incremented. So the content of the accumulator incremented, that means increment operation will be there, right? 0, the content of the accumulator is added. So that means increment operation will be there. And so that means just also increment, that means increment the content of the accumulator by 1, increment content of accumulator by 1. Okay. So already we know that 1, 1, 1, 1, 1, 1, 1 is there. So again we have to increment by 1. So that means add 1 in the again accumulator. But 0, 0, 0, 0, 0, 0, 0, 0. Carry will be 1 again. But increment operation, so I can write it. But increment operation, I can write, I'm removing it from here. So already I think I can note it down. So after that, for increment operation, You can say I and R. The flags are unaffected. Flags are unaffected. Okay. Carry flag basically. Carry flag is unaffected. Okay. By increment operation. So here S is 0 because there is no negative number. Carry is also 0 because it is unaffected by this increment operation. Okay. Now next one, zero flag. Zero flag, all the content in the accumulator is 0. That's why it is set. Okay. For 2. So let's go by the options. The first one is carry is 1 for, it is for 1. For 2, here I am writing S is 0, carry is 1, carry is 0. Okay, so these are the for two different operations. So for first one, carry is 1, sign weight is 0, 0 flag is 1. And for 2, same as the previous state, carry is same as, and sign flag is 0 z. So option 2 is the correct answer for this question. Okay. Okay. So I hope you have understand this question. So moving to the next question. So next question is also from the programming. Okay. So question is in an 8085 microprocessor, the following program is executed. So here address location is given, here the instruction is given. These are the options. Which option is correct? Okay. So they have at the end of the program register A contains. What will be the content? The register A. Okay. So let's perform the operations. So add location to 0 XOR A. So initially all the resistance accumulator is 0, 0 H, but here they have XOR A. That means XOR the content with the accumulator. So all the so and store in the accumulator. Okay, XOR with accumulator. So all XOR with will be 0. So A will contain 0, 0 only. Okay. Now next is MBI wait. Move immediate data in register B is 0, 4 and again the MBI A. Move immediate data, store immediate data 0, 3 in the accumulator. Okay. Now they have to RAR, that means rotate accumulator right to carry. Rotate right, that is rotate right to carry. Okay. So what data is stored in the accumulator? That is 0, 3. So accumulator is stored 0, 0, 0, 0, 0, 0, 1, 1. 0, 3 is stored. Now we have to move right to carry. So carry is 0 currently. So just move it like this. So now if we rotate once, so it will be the 0, 0, 0, 0, 0, 0, 0, 1. And in the carry block, it will be 1, right? If we rotate it. So we will rotate like this. Okay, now they have say that decrement B. So B decrement B. So that means B and store in B minus 1. So B is containing 4. So 4 minus 1, that is 0, 3. Right? Now here is they have jumped, if not 0 till B is not 0, till jump at the location 0, 2005. That means rotate again. After again rotate it, so carry is 1 and it is containing So 0, 0, 0, 0, 0, 0, 0, 1. If rotate it again, so through carry, so again carry will contain what? 1 because this one will come and this one will come in this place. 1, 0, 0, 0, 0, 0, 0. Okay. Okay, now again decrement b till b is 0 and again rotate. Okay. So here I am writing b is 0, 2. I am decremented again rotate it. So rotate it 1, 1, 0, 0, 0, 0, 0 and carry is 0 currently. Now decrement be 0, 1 again rotate it. So carry will be 0 again and it will be 0, 1, 1, 0 decrement and rotate. Decrement rotated carry will be sorry till b is 0. So 0, 1, 0, 0, 0, 0. Now decrement be 0, 0. So at 0, 0 again we need to rotate it. No, it will stop. That means b is 0. So now we can stop. Now end of the program. So what will be the value in the accumulator currently at the halt of the program? That is 1, 0, 1, 1, 0, 0, 0. That means 6. It is 0. So in hexadecimal that is 60. Right? In hexadecimal it is 60. So option 1 is the 60. So that's why option 1 is the correct answer. I can remove here so that you can see the options. So final answer we are getting 60 in hexadecimal. Here it is. So option 1 is the correct answer for this question. Okay. Okay. So I hope you understand this question. So moving to the next question. Okay, so next question is what will be the content of DE and HL register pair respectively after the execution of the following instructions? After execution of this following instruction, what will be the content in the DE and HL register pair? So they have said that LXIH load immediate data in HL register pair that is 2500H. Now next instruction is load immediate data in DE register pair is 0200H. Now next instruction is DART T. So DART stands for add register pair to HL register pair and save the data in a HL register pair. Add HL and D register pair. Okay. So and store the data HL in the HL plus D register pair. That DART means DART. So what is the content in the HL register pair? That is 2500 plus 0 to 0, 0. If we add 0, 0 to 5272 H and store the data in a HL register pair. Okay. So after this HL register pair contain 2700. Now XCHG means exchange HL register pair with T register pair. Exchange HL and DE register pair. Okay, so in the currently D register pair containing D is E have 0 to 0 0 and HL will contain HL to exchange the data. So in the D register pair after XCHG, D will contain 2700 and HL will contain 0 to 0 0. Okay. So these are the final content in D and HL register pair. So D register pair will contain 2700 and HL register pair will contain 0 to 0 0. So which option is correct? So option 4 is matching with this. So option 4 is the correct answer for this question. Okay. Okay. So moving to the next question. So next question is, consider the following instruction, that is EI move 8 to 08, then it means, what does it mean? So option 1 is disable all interrupts, option 2 is enable all interrupts, or option 3 is disabled RST 7.5 and 6.5, or option 4 is enable RST 7.5 and 6.5. So EI stands for enable interrupts. It is stand for enable interrupt, and that means move immediate data A is equal to in accumulator 0, 8. Now next, set interrupt mask. SIM stands for set interrupt mask. Set interrupt mask. That is set. Okay. So what is this SIM? Already been, if you have gone through this, the SIM instruction also has a one one data like a flag register type. So one, two, three will be there. Okay, and accumulator contains 0, 8. That means we in the binary 0, 0, 0, 1, 0, 0, 0. Okay, right? So what's the in instruction register contain? So that is SOD, serial output data. Serial output data. And this is SID. Okay. Here it is, I think, enable interrupt, SID. And here unidentified, undefined, undefined. Okay, here it is the RST 7.5, here mask enable, here RST 7.5 mask, RST 6.5 mask, and RST 5.5 mask. What is the accumulator content? So just put the bits above the instruction, that is 0, 0, 1, 0, 0, 0. Okay, so serial input data, serial output data has is 0, so that means there is no serial output data. Here it is also serial input data is also not enabled, only mask enabled. Okay, so that means enable all interrupt. Okay, that is stand for enable all interrupt. Okay, because it is only here it is enabled. Okay, not RST 7.5, 6.5. Okay, so that means enable all interrupt. Option 2 is the correct answer for this question. Okay, just see that what accumulator data content and put in the SIM instruction register and check. Already here enable interrupt instruction is there, so enable all interrupt. Okay, so moving to the next question. So next question is, what is the content of accumulator of 8085 microprocessor after the execution of the XRI F0 instruction? What is the content of the accumulator of 8085 microprocessor after the execution of the XRI F0 instruction? So option 1 is clear the lower 4 bits of the accumulator in 8085. Option 2 is complement the upper 4 bits of accumulator in 8085. Option 3 is clear the upper 4 bits of accumulator in 8085, or option 4 is complement the lower 4 bits of the accumulator in 8085. So what the execution of XRI F0 instruction? Okay, so XRI F0 is used to complement upper 4 bits of accumulator. Okay, so let's take an example, check how it will complement. Okay, let's accumulator have 08 content of, let's example, let's. Okay, so let's, you can take any example and check whether F0 operation will complement or not. So that means A is 0 0 0 0 1 0 0 0, and XOR F0, so that means XOR with F0. F stands for 1 1 1 1 and 0 0 0 0, F0 XOR. And check whether it is complemented or not. 0 0 0 0 0 0 0 1 1, XOR operation will be there, 0 1 1 1 1 1. So check, it is complemented. Four bit, upper four bits are complemented. 0 0, it is 1 1 now, and all other bits are same. Now you can take the another example. Example 2. Just take, you can take it. What you can take it? Just take example, accumulator is equal to 80. Let's check whether it is complementing or not. That means 1 0 0 0 and 0 0 0 0. Okay, now it's a live operation F0 1 0 0 0 0, right? XOR it, that is 80 in hexadecimal or F0. Okay, so 0 0 0 0, that is 1 1 1 1 1 0. So we can see that it is complemented. It is complemented, that 1 is 0 and all of the 0 0. Okay, so it has been complemented. That means complement the upper 4 bits of the accumulator in 805 8085. Okay, so option 2 is the correct answer for this question. Okay, so moving to the next question. I hope you have understand the previous question. So moving to the next question. So next question is, consider the situation where a microprocessor gives an output of an 8-bit word. This is fed through the 8-bit digital to analog converter to a control valve. The control valve requires 6 volts being fully open. Okay, so if it is a fully open state, it is indicated all 1. So the output to the valve for a change of 1 bit will be, what will be the output for the change of 1 bit? Okay, so it is given for an 8-bit digital to analog converter. For 8-bit T digital 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 to analog converter, there will be 2 to the power 8 combination are there. Now there, and 256 combination is all 1, right? Yeah, all 1, which is fully open. That means which is fully open. fully open state. So for fully open state, there is a 6 volt. The control valve is fully open. Okay. For fully open, control valve requires 6 volt, right? So that means at 256 bit, there is 6 volt required. So for 1 bit, how much required? That is 6 volt by 256. I am writing here. Okay. 2, so it's for 6 volt, 256. So 6 volt. So what will level, if you divide it, you will get 0.023 volt. For the output to work for one change of one bit is 0.023 bit. Volt is required to change the volt. So option C is the correct answer for this question. Okay. Okay. So I hope you have understand this question. So moving to the next question. Okay. So next question is in 8086 microprocessor, if DS is 1100H, DX is 0200H, and SI is 0500. The address accessed by move CH DX plus SI is what will be the address? Okay. So it is given already. DS is equal to 1100, PX equal to 0200, SI is 0500H. So BX plus SI plus SI. So you will get 0700H, right? Okay. So for instruction, move CH to BX plus SI. So what will be the move the address? That means move address in CH location. So what will be the address? The physical address will be for this. The physical address accessed will be D can be calculated by DS into 10H plus dx plus si. Okay. So ds is given as 1100 multiplied by 10h. Okay. And the vx plus si is 0700h. So 11000h plus 0700h. If you add, you will get 1. How much you will get it? 11700H. Physical address will be the 11700H. Okay. So option 2 is the correct answer. Physical address can be accessed by this. This is the one formula you can see that. Okay. So option 2 is the correct answer for this question. Okay. That means move CH means this is a move address in CS. So we need to find out the physical address for VX plus SI. So this is the formula ds into 10h plus vx plus s. Okay, so this is the physical address accessed by system. So 11700. Okay, okay. So I hope you have understood this question. So moving question. Next question is there. So next question is after the execution of the given statement, determine the status of the PSW. So what is the execution? Move A So data hashtag 0VF, that means move the data into accumulator, that is 0VF in the accumulator, and add A. Add A means add 1B to the accumulator and store the data in the accumulator A plus 1B. So current data in the accumulator is BF, BF, 0BF, so 1B. Okay, so we can directly add in the hexadecimal, otherwise we can convert it. So B stands for 1011, that means 11, and F stands for all 1. And 1 is 0001, right? And 0, 1. Just add it 0, sorry, plus 1, 0, 1, and 1. This is a final addition, and that will store in the accumulator. That means accumulator is equal to this one. This is 110 is B and A. 110. So 101 will be 412, 13. That means D, not D. D, A in hexadecimal. Okay. So there is no carry. So carry is equal to 0, right? And the carry is forwarding after 4 bit. As carry is forward in the 4 bit, so auxiliary carry will be 1. And the parity, there is a odd number of event parities, so it will be the 0, odd number of ones, because of odd number of ones. So what will be the status of PSW? What PSW will contain? PSW will contain PSW, SW, accumulator plus flag, accumulator plus flag is a PSW, right? So PSW register will contain CYAC, that means carry, auxiliary carry, then F0, then RS1, RS0, that means register. Okay, then we contain the, it will contain overflow, then I don't parity. So parity is 0, just put carry is 0, auxiliary carry is 1, F0 is not defined. So 0, 0, 0, overflow, if there is no overflow, here it is 0, and parity is also 0. So what will be the content of the PSW? PSW is status is 0, 1, 0, 0, 0, 0, 0, 0. Okay, this is the status of the PSW. So which option it is matching? It is not option 2, the option 3. Here it is option 3 is the correct answer. Okay, for this question. Okay, so option 3 is the correct answer, not option 2. Here option 3 is the correct answer. Okay, okay. So I hope you have understand this question. So this, okay, so these are the questions for this week video lecture, based on this week video lecture. So I hope you will get it. You will able to understand this question. The questions are completed. There no one has taken this session, so there is no doubt. I hope. Okay, okay. So I'm closing this session right now. So I hope you will understand by seeing the video. Otherwise, you can ask if you have any doubt. You can ask in the extra session. Okay. So thank you for joining this session. Okay. Thank you. Thank you everyone. And going to close this session as no one else joined this session and there is no doubt. So I have completed all questions. So I hope you will understand in the video. Thank you. Yeah. Thank you everyone. Thank you for closing the session.